Hi, good morning everyone. I am K. Narsimurthy, presently working as an assistant professor in Government First Grade Women's College, Tumkur. The video which I am presenting is in the subject physics, and this is my 54th video for the second semester students of Tumkur University. So in this section I am discussing completely the numerical problem regarding to the alternative circuit. This AC circuit, which which is a very small chapter, which I have finished with the 3 videos. In the first video, I discussed a very basic thing of the alternating current. Second, I have derived a J operator method of series LCR circuit, and you don't have the parallel LCR circuit derivation in your exam, in your syllabus. It was there in the old syllabus. It was there in the old CBSE, but this time in the new CBCS syllabus, it has been removed. The parallel resonance circuit has been removed in the revised CBCS. So that is why I am not touching into the derivation of parallel LCR circuit using J operator again. So, and I discussed a resonance circuit, series resonance as well as parallel resonance, and defined some of the factors like quality factor, bandwidth, resonant frequency, and the expression for them. Now, after discussing this small chapter theory, let us look into some of the problems, because this problems carries a very important and a considerable weightage in the exam. So you need to attend at least 4 problems. You need to do 4 problems in the 6 out of 6. Out of 6 you have to do 4 problems. So each carries the 5 marks. The 20 marks is completely for the numerical problems. You can easily score out of 4 marks in this section by solving these problems. Right. So we shall start these problems of the alternating current. In a series LCR circuit, the values of components are R equals to 100 ohm, L equals to 1 Henry, and C is equal to 25 microfarad. The circuit is in connection with the alternating source. Determine the impedance at resonant frequency, quality factor, and bandwidth of the circuit. Okay, you need to find out a lot of things here. One is impedance, quality factor, and the bandwidth. Of course, the resonant frequency also. Right. So first let me find out the resonant frequency. I told you students, whenever you are going to solve a problem, first write down the data. I'm sorry, I am not written the data here in the PPT because it's a waste of space. Now you on your sheet while solving any particular problem, you please mention the data and you search for the relevant formula. So we have only the formula for resonant frequency is Fr is equal to 2 pi into root LC. Okay. Substitute it. 1 divided by 2 into 3.14. Root of L is 1 Henry. Capacitance is 25 microfarad. You have to convert this 25 10 to the power of minus 6. If you do the calculation with your scientific calculator, the scientific calculator is allowed for the exams. Now you are in the degree, now you are in the BSc, you are allowed to take a scientific calculator in the examination hall. But that was not supposed to be there in the PUC level. In the pre-university level, you are not supposed to carry the scientific calculator to the examination hall. But here in the degree, here in the pre-university, here in the undergraduation level, you are supposed to carry a scientific calculator in the examination hall. Okay, fine. So you can easily do it with a scientific calculator, and the value of frequency is 31.8 Hertz. Okay. Now at resonance, I'll say impedance at resonance. They have asked me to calculate the impedance at resonance also. Impedance at resonance will be simply equal to the resistance. Yes, that's a very simple thing, but you should know that. Students, you should know this concept that at resonance, the impedance is equal to the resistance of the circuit. So impedance Z is equal to R at resonance, because XL is equal to XC. At resonance, inductive reactance is equal to the capacitive reactance. When you equate in that Z equation, root of R square plus XL minus XC whole square, the second term XL minus XC becomes 0 because XL is equal to XC at resonance. Then you are left with only the resistance term. So Z will be equal to root of R square, Z will be equal to R. So at resonance, so your impedance will be equal to the resonance, equal to the resistance, which is 100 ohm, in fact, not the 10 ohm. You please make the correction here also. It is 100 ohm. Yeah, there are few more things to calculate. The quality factor, which is a measure of sharpness of the curve, is XL divided by R. It is inductive reactance to the ohmic resistance. I have defined in my previous video that the quality factor is XL by R. XL is what? XL is omega L. Omega is 2 pi F. So omega is 2 pi F into L, it is 2 pi FL. So go on substituting one by one in that equation. 2 into 3.14 into the frequency which I have calculated is 31.8. It is the resonant frequency. I know resonant frequency. You are calculating the quality factor at resonant frequency itself. 31.8 into 1 Henry. Inductance is 1 Henry divided by resistance is 100 ohm. So if you calculate the Q, you will get 1.99, which is approximately equals to 2. The quality factor I got 2. After getting 2, I can easily find the bandwidth. We know the equation for quality factor as resonant frequency by bandwidth, FR divided by bandwidth. So if I want a bandwidth, I just cross multiply and I can write it as FR divided by Q. Q I just found out. FR is 31.8 divided by Q is approximately 2. If I substitute that, I can get the bandwidth as 50.9 Hertz. I told you the bandwidth is decided by the value of resistance. If resistance is more, bandwidth is more, because more broader is the resonance peak, resonance curve. And that was the sharpness. Quality factor is less means sharpness is less. Yeah, let us move on to the next problem. A inductance of 10 Henry connected in series with a resistance of 50 ohm to a 220 volts 50 Hertz AC source. Calculate the value of the capacitor to be connected in series to make the power factor 0.5, and also calculate the current in the circuit. Right? Yeah. The first thing is to write down the data. Inductor is given, resistor value is given, and the applied voltage is 220 volts and the applied frequency is 50 Hertz. Alright. So one thing I forgot to mention in the theory is that the power factor is cos phi. So where phi is the phase difference between the current and voltage in this particular series LCR circuit. So cos phi is the power factor. So power factor is given, which is 0.5, and this cos phi is equal to 0.5. So where phi will be equal to cos inverse of 1 by 2. So cos inverse of 1 by 2 is 60. Phi will be 60. Okay. So right, I got the phase difference between the current and voltage as 60 degree. Now, one thing is over. I got the value of phase. Second thing, I can find out XL, because XL is omega L. XL is 2 pi FL. I know the frequency and inductor. Substitute it, 2 into 3.14, and the frequency is 50 and the inductance value L is 10. If you substitute that and calculate, I got an equation for XL as 3140 ohms, 3140 ohms. It is an inductive reactance. the unit for this inductive reactance is ohm, because it's a kind of opposition to the flow of AC current. Yeah. After finding this, let me find Xc, which is called capacitive reactance. So I know that this tan phi is XL minus Xc divided by R. It is a series LCR circuit. I have been derived using the J operator method in my last to last video. So I got this tan phi, which is the phase difference between the current and voltage, as XL minus Xc by R. XL I just calculated. I need to know what is Xc. So phi is known, which is 60 degree, XL is known, and R is known. I can easily calculate Xc just by cross multiplying and taking Xt to the left hand side, sending all these terms to the right hand side. If you do it with your calculator, you will get Xc as 3053.35 ohm. Okay, that is the value of capacitive reactance, Xc. So once I got Xc, it is easy for me to calculate the value of capacitance. Xc is equal to 1 over 2 pi Fc, very direct formula, where you take Xc and send this, you take C to the left hand side, send this Xt to the right hand side denominator. So find the value of capacitance. So the capacitance value which I got is 1.043 microfarad. Students, you please once check these numerical answers, because I may be wrong in doing some small calculations, but once you check all these answers with your calculator, okay, you please verify my answer with your calculator once. Don't blindly write the answer. Okay, so you cross check the answer once and write it in your notes. Yeah, one more thing I need to calculate here is the impedance. Here the impedance I am doing not at the resonant frequency. I am doing the impedance at the given frequency, which is 50 Hz. 50 Hz is not the resonant frequency. So for doing an impedance, you need to take a complete formula, which is R square plus XL minus Xc whole square. But in the last problem, I took the impedance as resistance only, because it is told me to calculate the impedance at this resonant frequency. That is why I took Z equals to R in the last problem. Whereas in this particular problem, they have asked me to calculate the impedance at this given frequency of 50 Hz. So now I am doing this. Z equals to root of R square plus XL minus Xc whole square. R is 50 square plus XL I just calculated, Xc I calculated, substitute all the values, and I got the value of Z as 100.04 ohms. The unit for impedance is ohm again. So for unit for resistance is also ohm. Unit for inductive reactance, XL, is also ohm. Unit for capacitive reactance, Xc, is also ohm. Unit for impedance is also ohm. So you are using ohm as an unit for all these four quantities. Now after getting Z, it is easy for me to calculate the current just by Ohm's law. Current is V by Z. I am using Z, not the R, because I am looking for the current with the presence of all the three components. If all the three components are there, then the opposition offered is Z. I have to take impedance, not just the resistance. If you take the resistance, you are only looking at the resistance. So remaining other two components you are leaving, you are forgetting other two components. If you take Z, you are taking into account all the three components in the circuit for finding the current. So I is equal to V by Z, which is 220 by 100.04. I got the value of current as 2.199 amperes. That was the current flowing in a series LCR circuit. Yeah, we'll move on to the next problem. The third problem: a 48 ohm resistor connected in series with an inductance of 450 millihenry and an capacitance of 9 microfarad. First thing, what is resonant frequency? Second, What will be the current in the circuit when a source of 120 volt operating at resonant frequency? Third, what is the voltage across the inductor under this condition? Alright. Now, the first thing I have told me to calculate the resonant frequency. So, very simple formula for resonant frequency is Fr is equal to 1 over 2 pi root LC. I can easily apply the formula 1 over 2 into 3.14 into root of L is 450 millihenry. Please you substitute for milli as 10 to the power of minus 3, which I forgot to substitute in this equation. Okay, you students, you please substitute inductance as 450 into 10 to the power of minus 3 without fail, because it is forgotten to mention in this particular equation. And 9 microfarad is 9 into 10 to the power of minus 6. If I do overall calculation with a scientific calculator, I'll get the answer FR as 79.07. 2 digits is okay. So after decimal point, if you mention 2 digit, it is enough. 08 hertz you can make. 79.08 hertz. I got resonant frequency, and after that I am going to find the XL. XL is the inductive reactance. The formula is omega L, which is 2 pi FL. Keep on substituting 1 by N F. See, this time L I have substituted 450 millihenry. Milli is what? 10 to the power of minus 3. In this equation I have completely substituted inductance, where I have forgot in the last equation. You please correct it. Okay, XL is 223.61 ohm. I got the inductive reactance. Next I am going to find the capacitive reactance. This time capacitive is 1 by omega C, 1 by 2 pi FC. Okay, 1 by 2 pi F I know, F I just calculated. F is resonant frequency. Yeah, I am substituting resonant frequency because frequency is not given. Suppose if frequency is not given and I am told to calculate all these quantities at resonant frequency, that is why I am calculating this XL as well as XC at that particular resonant frequency. Right. So capacitance is 9 micro, I feel. This is 9 microfarad. You please correct it. It is not milli. It is 9 into 10 to the power of minus 6. You please correct it. And XL is 223.76 ohm. I am getting almost same value for XL and XC. This is XC. The last one is XC. Why I am getting the same value is because I told you that at resonant frequency the both XL and XC are equal. So I am calculating these values at resonant frequency. Both has to be equal. I am getting almost same value. Now I am calculating Z at this frequency. Z I told you which will be equal to only the resistance at resonant frequency, because I am getting XL at the same value as XC. So Z is 48 ohm, which is the value of resistance. So once I got Z, I can calculate current flowing in the series LCR circuit as V by Z, 120 by 8, which is 2.5 ampere. So once I got current, I can calculate the voltage potential across the inductor, or I can calculate potential across capacitor. Anywhere I can calculate the potential. So VL is equal to I into XL. Be careful, you have to take I into XL, not Z. Okay, if you take Z, it is whole potential of the source. If you take I into XL, it is potential across inductor. If you take I into XC, it is potential across capacitor. If you take I into R, it is potential across resistor. Okay, so this particular problem, I am only calculating the potential across inductor. VL equals I into XL. So if I calculate, I got the value of VL as 559.02. What is the unit for potential? It is volt, not the ohm. So again there is a mistake here. You please correct it. It is not the ohm, it is the volt. Next, in this last problem, I'll read out the problem first. Calculate the resonant frequency of circuit in which a coil of inductance 0.9 Henry and a capacitor of 0.4 microfarad are connected in series. Okay, so I need to calculate only one thing here, which is the resonant frequency. It is a very simple problem compared to all these problems, all the last three problems. Very direct formula. Take the resonant frequency formula, Fr as 1 over 2 pi root LC. Substitute L as 0.9 Henry and the capacitor as 0.4 microfarad. Very simple calculations. I got this resonant frequency as 265.3 Hertz. You please students, you check this all the numerical calculation once with your calculator. Right. Yeah, this is actually the last problem, the fifth problem. Right. A coil of resistance 10 ohm and inductance of the coil is 0.5 Henry. It's supposed to be Henry, and capacitance of 9 microfarad connected in series. Calculate the current when it is connected in a source of 220 volts 50 Hertz. It looks to be a very simple problem. If you look at this, it is a series LCR circuit. Okay, so only thing I need to calculate here is the current. Okay, so how do I calculate the current in this series LCR circuit? It is simple Ohm's law. The current is voltage divided by impedance, not simply the resistance. It is voltage divided by impedance, because the impedance is what the opposition to the flow of current by all these three circuit elements like resistor, capacitor and inductor. That is why you need to take Z here. So to calculate Z, I need to know the value of XL and XC. I need to calculate the inductive reactance as well as capacitive reactance. Then only I can calculate the impedance of the circuit. After finding the impedance, I can easily calculate the current which is flowing in the circuit. Right. So first I will calculate the impedance. Impedance XL is equal to 2 pi FL. Okay. Right. So student, you need to remember these formulas. You write down all these formulas of inductive reactance, capacitive reactance, impedance and current in the circuit. You write down a set of formulas before going to the problem of this section. So I am giving you the suggestion that before going to any numerical problems, first write down all the formulas which come across and in that particular chapter. So it may take half a page or a full page. First list out all the formulas of that chapter. So after listing the formulas, then you go to the problem and then you go solving the numerical problems. Okay, that is the best idea actually. Alright, XL is 2 pi FL, 2 into 3.14, F is given 50 Hertz and L is 0.5 Henry. So easily I got XL as 157 ohm. So ohm is the unit for inductive reactance, but without fail you should mention all the quantities with unit. XC is 1 by omega C. It is 1 by 2 pi FC. Okay. So you can substitute 1 by 2 pi F as 50 Hertz. Capacitance is 9 microfarad, 9 into 10 to the power of minus 6. I got this capacitive reactance, sorry, you make it as XC. Lot of small correction is there. You please correct it. XC is equal to 353.8 ohm. Okay. So XC is what the inductive capacitor is. Again the unit of that is ohm. So after knowing XL and XC, I can easily calculate the overall opposition, which is the impedance. Impedance Z is equal to root of R square plus XL minus XC whole square. Go on substituting one by one. I know value of R, I know value of XC, I know value of XL. So go on substituting one by one, square it, add it and make a root of it. So your answer is 197.05 ohm. Z unit is also ohm. and finally at the end I am coming to the current. Now I am coming to the current. This is the current which I supposed to calculate. This is the current which I asked to calculate in the problem. So for calculating the current I am doing all these things. Okay, so I is equal to V by Z. It's a simple Ohm's law formula. 220 by Z I calculated 197.05. In one single step I got an answer of current as 1.116 ampere. I was calculating the current. For that I need some impedance Z. When I go to calculate Z, I need XL and XC. So I started doing from XL and XC, and after that I found Z, and then finally I calculated the current which is flowing in a series LCR circuit. Right. So these are some of the problems which I discussed. Almost your problems which you can expect in the examination will be of this type. Okay, maybe a numericals will be small numericals will change, but the method of solving this will exactly the same, and they are going to ask almost the same kind of problems. Okay, you get some more problems when you go to these books. These two books, the second and third, are almost the textbooks. No, not X.C. Verma. The third book is almost like a textbook. You go through that, you can get a number of problems. Even you can get a solved problems and exercise problems. Solve it. I suggest you to solve some exercise problems, so you will get a skill of problem solving. So if one skill is developed, it is very easy to tackle any kind of difficult problem. Okay, right. So thank you very much.